All right, math fans, let us continue on here with the next one. I'm just going to add one simple word, and I'm just going to say graph. Let's give us something easy to do here. So we're going to graph this function. Well, how are we going to graph this? Well, weird that Mr. Morin gave us this very specific graph, y is equal to the square root of x. Likely, we're going to graph using transformations. So although it's not explicit, using transformations may help us here. So dot, dot, dot. I'm just going to change this. This is not in regular form, right? I am just going to change this. Y is equal to, I'm going to add 2 to both sides. See if that looks more familiar. Much better. What I can pick apart here is my A, B, and K. A is equal to -1. B is equal to 2. K, there's no H here, K is equal to 2 as well. So very quickly, I am going to pick out the very important points on this graph. I'm going to put a little arrow at that end to signify that it's continuous. The reason why my graphs don't have arrows, the graphing software I use don't apply arrows. Okay, so here it is, and I can say A is equal to -1. I should probably write something down here to let the person marking this know what I'm doing. I'm just going to reflect in x-axis. I'm going to switch colors, maybe green. So I'm going to take point, we start off with point x, y, and we're going to move it into, now reflect in the x-axis, point x comma -y. So I know the word just said graph, but look at all the work that I'm doing. I'm trying not to make a mistake here. Often that's the case in math. We know our material really well, but we just have to try to stop ourselves making mistakes. There. That is a graph that matches up with my words of reflecting in the x-axis. Now, B is equal to 2. Now, B is equal to 2. That's a separate transformation, right? So B is equal to 2. Now, I'm thinking very carefully on this. I know half of you are going to make a mistake on this still, but I am going to call this stretch by, now I'm going to say, sorry, horizontally. I'm going to get caught with that on the provincial exam. Horizontally stretch by a factor of 1/2, or compressed by a factor of 2. So now I can take this point, and this point becomes x divided by 2, comma, -y. So now, take the x value, and I divide it by 2. -1, take that x value of 1, divided by a half, divided by 2 becomes a half. Now this was another, I should have made my points far more clear. For -2, I divide the x value by 2, it becomes 2. 9 divided by 2. Anyways, there we have it. And by the way, the person who's marking this may not pay attention, so I'm going to make those points really nice and obvious. And for you, I'm going to switch the colors, or just put a little dot. Hopefully that helps. There we have it. Oh, almost done. I almost quit before the race. Anyways, I need to take care of K. So K is equal to 2. We just shift each of these points, so this is a shift up 2 units, So we took point x, our x values stayed the same, but our y values, we add 2. So I'm just going to go 1, 2, shift this up. Now, if you notice, I was silent there and I worked very, very quickly. And I shifted up 2 units. I just counted 1 unit, 2 units. Just kept the x where it was. 1 unit, 2 units. Kept the x where it was. 1 unit, 2 units. So it just makes it really quick and easy sometimes if you just think about them in units and maybe not do the math. There we have it. There's my final graph. I hope you enjoyed. Now let's see what the final question has in store. Whoa. Well, let's make things easy on us. Let's just get rid of this one. They look the same. So, gone. Okay. I should have used that as white space. But regardless, determine the radical function from the graph. I'm not too sure I understand. Guess what I'm thinking of? Here's me. The only thing I'm good at is transformations. Actually, I'm pretty good at a lot of things. A lot of us are. But right now, the year has focused on transformations. And I know how to graph really, really well y is equal to the square root of x. So I'm going to sketch that out. Do it on your graph right now. Press pause. I sketched out the basic square root function, y is equal to the square root of x. Now I need to try to get the equation of my new radical function, and I'm going to maybe start picking out points that I can see. And I am sure some of you guys are putting it together. Now I am going to think about the transform form. Y is equal to a f b x minus h plus k. Now, which ones must I do first? Well, you need to do the multiplicative ones, a and b first, and then you can think about the transformation of h and k. Well, there's actually 2 different equations that we could write to make this true. But remember that a and b are what I like to call as shape, right? They govern the shape of the graph. There is no reflection about the x or y axis. I hope you can tell that. But it does seem like we stretched this. Sorry, I say it does appear like we stretched it. Some people may say, no, we didn't. We compressed it. But anyways, how did this change? So I'm just going to think aloud here. I'm going to maybe take yellow, if you can see yellow. Hopefully yellow. Yellow, I said. So if I go over 1 unit, I notice that I went up 2. Right? Sorry. On the base family, I went over 1, up 1. But on this one, I went over 1, up 2. Now you have to forget where we are, right? It's really confusing if you try to look at the coordinate system behind us. The next one, I went over 4 on the family one, the parent one, and then I went up 2. Let's see if I go over 4. So I go over 4 on this red curve. So when I go over 4, now, I'm going to switch colors, I went up 1, 2, 3, 4. So moving from y to this new radical function, my y values increase by a factor of 2. So really, I'm thinking this. I am thinking that a is equal to 2. We have a stretch of 2. That's what I'm going to go with. Maybe, so anyways, I'm going to start the process. Y is equal to the square root of x is the black. And now I'm just going to erase my doodles that I have here, and hopefully they're enough not to distract. My erasing is enough to get rid of all the distractions on the graph. All right, there it is. So I start off with y is equal to the square root of x, and now I'm going to change it, y is equal to 2 the square root of x. And I'm just going to graph that to help me out. If I graph that, I'm just simply multiplying the y values by 2. And I'm hoping that you're able to see that the blue graph and the red graph have the same shape. So now I just have to denote, hey, what shifts did we do? And to me, the most important point is this starting point right here, the beginning of it. It went from 0, 0 to 0, 1. So to me, that naturally implied that k is equal to 1. So the final function should have form this. Great. I'm going to try something a little bit risky, if you guys don't mind, with this. Okay? Oh, no, I don't want to erase that. Anyways, very quickly, I'm going to switch to a black pen. And I like this because it shows you the verse, like nothing in math is easy and straightforward. Here's my y is equal to the square root of x. Some people in class say, oh my God, that's not how I saw it at all. Instead, what I saw was to go from, they took this point. Now, you might have to really stretch your thinking here. It's really bizarre. Because I went over 1 unit and I went up 2. That was on the transform graph. In other words, but when I went, here's my parent function, I had to go over 4 units to go up 2. Okay, I thought about that backwards. So some people say, I had to go over 4 units to go up 2. But on the transform graph, I had to go over just 1 unit to go up 2. In other words, I compressed the graph by a factor. Now, people are going to yell at me, horizontally compress by a factor of 4. And if you do that, you start off with y is equal to x, and if you compress it by a factor of 4, that is the coefficient in front of the x. Pretty cool, eh? So I'm just going to graph this ever so slightly. Oh, no, wrong one. Didn't want to erase that. Wanted to erase this, though. Now I'm going to just make a quick transform. So I'm going to stretch this over, or compress it by a factor of 4. Take this point, compress it by a factor of 4. Compress that by a factor of 4. Compress this by a factor of 4. That really hurts my brain. I don't know if I can do that. So 9 divided by 4. Blah, blah, blah. Maybe there or something, right? But then I have this beautiful curve. Yikes. And then I have to shift it. This part is really important. I just have to shift it up 1 unit. Look at the two equations. They are the same. For instance, if you factor out that 4, so this is compression by a horizontal compression by a factor of 4. But if you forget all this transformation talk and just work with the expression on the right-hand side, and you take the 4 out of the radical, you'll end up with the same equation. Look at that. Fantastic.